Hi everybody, in this video we demonstrate how to model a multi-story building and with a staircase on the left bottom corner for a multi-story concrete building. So we're trying to model this one with the given configurations here. And however, to simplify the problem, what I'm trying to do is that I'm just model the corner here, just a 2 by in here. And also I'm going to do maybe just model 2-story, and you should be able to work on to find out the continuous the other levels or to the other areas if you want. So this is a joint and 4 meter by each, and then the staircase you have a 2 meter up and 2 meter up, 2 meter down here. So that 2 meter down here. Okay, so that was the 3D view is here. You come up here and then turn around and then come up the next level. So that's the way you work on. So let's have a look at how we model this one in Autodesk Robot. So let me bring up the Autodesk Robot here. So it takes a while to load up. So once we load up, we should choose the building design this as a new project. So once you come in, and the first thing we need to do is to define the coordinates. So to define the coordinates, what we're trying to do is that as we said, we only need 2 by. So this is 2 by, and as we said here, that was 4 meter, and then 2 each here, and then another 4 meter here. So this is 1.5 meter plus 3.5 and then 2 meter again. So after we understand this one, let's try to generate the coordinate system. So we only create one story first, then we can copy and paste and to the next story. So the x, the one we have is the first thing is 2 repeat, and then distance 2 meter. Then we add these 2, so we got 4 meter in total, and the next one we add on 1 repeat and 4 meter for the next base. So we add to this one, so we get 8 meter. So why we have that 1.5 meter first? So we have 1 repeat of 1.5 meters, so we add on this one. Then the next one we're going to have a 1 repeat, and then the flight of the stairs is 3.5 meters, so we add on this one, and then we add on the corridor, that is the 1 repeat and 2 meters. So in total we get 7 meters in that. So it's a y direction z, so we leave it as this, so base and to the 3 meters first. So let's click on apply, then we got the coordinate system we need for this one here. So then the next one we're going to put on the column, and to put on the column we need to choose the proper one. So we put in RC column, and then the dimension we're going to have is rectangular. So as we mentioned in here, so all the dimension here are going to be 500 and times 500. So after that one, so we can click on add, and that's columns has been generated. So once we got this one, what we need to do is that we need to put on column on all this one. So and then in all this design, what we're going to have is that we have a column on this major column line here. So we just need to add the column to each one of them. So to do that, we need to activate this window. So we just drop the point here. So 1, that one, jump over this one, 2, 3, and so on and so forth. So that's pretty easy. So once we have done the column, and then what we need to do is that we need to generate the beam. So to generate the beam, so we can need to use this icon. So let's close this window. So let's click on this one, the beams, and then again we use RC beam, and then the new beam we have in here is, as we said here, that was the B breadth of it is equal to 350, and the height of it is 600. So for all bins, that let's click on add and then close it. So we generate a bin here already. So we just need to link this one by one, and then this is a horizontal bin. So to do that, what we can do is that we can maybe put in the drag mode, so we can start from one to another. So one circle and an ESC, and then the next circle and ESC, and then we draw this one and ESC, and this one, this one, this one, this one, this one, and the middle one here as well. So the one in here need to be linked. Okay, so this is the floor plan we have so far. So it's difficult to see what this looks like as a one-story building. So we can click on the wheel, and then you can hold on the Shift key, and then use the middle buttons of hold on the middle buttons of your mouse. You can see the structures and for this part. So as we can see here, that the one we have in here, this corner, oh, I think I should be able to change to the 1 and 1. Let me check. So X, Y, Z. So that's the corner here. So this corner here, we're going to generate the staircase. So let's maybe do the staircase first, and then to enable us to create the new structures layer by layer. So to do that one, what we're going to do is that we need to use the slab which is in here. So let me just define a new slab. As we said, all the slab, the thickness, and in here it is all equal to 150 millimeter thick. So we just click on add. So that's the labeled. So labels with thickness is 1.5, and then we just maybe add to this one and close. So we need to choose this one to proper thickness, and then we can actually start to generate this slab. Just pay attention to this one. There was one function is very important, is horizontal slab. So when you tick this one, which means your slab has to be generated in horizontal direction. So in here, what we're going to do is that we generate in this way. So we put a slab here, this one, this one, this one, and then you need to click back the last one to form a circle. So this is the first part of it. And then the next one is going to move up halfway through to somewhere here. So to generate this one, what we need to do is that maybe we close this one first. We have a look at the 3D drawing. So in the middle, we have no way to land the structures. We have no way to land the structures in here. So we need a column where in the middle of this one, to provide a support to this one. So that's going to be from here to here, so to support this beam. So to do that one, what we need to do is that we add on one more column. So let's have a look at the plan view. So let's maybe come back to plan view. So which means in here we need one more slab to support this one. So what we're going to do is that we choose the column to make sure the column is the one we already defined. So we put in a column here. Okay, so one more column, and then we come back to the wheel. Then you see that this one going to come up to the middle way of this one, and then form another platform. So that is nearly ready. And along this one, sometimes we possibly want to put the beam across this one. That's we can do that one later on. So what we're going to do is that we just create the slab first. So let's close this one. To generate this one, so we need to use the floor. and then make sure this is the right thickness, and then untick this horizontal slab. So we can start from this point and this point, and then now we're going to move up to the halfway of this column, and then halfway of this column, and then come back to the bottom one to generate that slope, which is the staircase on here. And then what we need to do is that we need to create that connections between here to here. So we can presume this one, the one most left, and then this time make sure we can snap to the middle point of this one. So that's maybe easiest way. So we can just trying to rotate it, make sure you can snap to that point. So that's the next point you want to snap to. Sorry, I pressed the ESC key by mistake, so that has disabled the function I have before. So let's maybe redraw this one. So make sure you choose the proper that thickness, and then just click on that this one. If it's right thickness, yes, just leave it on. So what we need to do is that we need to generate a slab, cover this area to here, to this point, and to this point, of one single plate. Just connect around this one, so allow the people work on up and then turn around and then come up again. So let's do this one. So we start from here, and the next one here, and this one is a horizontal slab, so you can choose the horizontal slab in here. So that link to this point, and then link to this point, and then link to this point, and come back to the point. So generate this slab again. So once we come to this point, then what we need to do is that we need to generate a slope from halfway through up to here. So this time we need to disable this one, horizontal slab. And normally what we can do is that we can click on here and here. This time is make sure horizontal slab is disabled. So up to this corner and to the middle one here, and come back to here. So you got this one set up already. So once you done this one, so we need to generate a slab in here. So which is half of it. So to make sure that next time we copy up this one, you can copy everything to the next floor. So what we can do is that we can select this one, this one, this one, this one, and come back here. So you get one staircase generate already. Okay, so you can see pretty clearly in here. After that, we need to create all the slab in here, all the slab in here. So what we need to do is that because it's all the same thickness, so we can just quickly, quite easily generate this one by take this horizontal one, because only in the horizontal slab we have now. So we choose from here, 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 here. The next one. Okay, and then the top floor. Okay, so if you want to have a look at the whole building, so that's the one generate in here. Okay, so normally what we have to do is that along this line, the one single slab to support this one, normally we consider is not strong enough. So in general, we should put in that some column support in here, and then beam connecting here. So what we're going to do is that we're going to maybe create some beam to support this one from this point to this point. Okay, and from this point to this point. Okay, and then also it's better to put in beam from here, but make sure horizontal beam is unticked. So you create here, another bin here. Okay, and then one bin from here to here, and then one here to here, and then one here to here, and one here to here, one here to here, and one here to here. Okay, so and then if you want to have a look at the 3D view, so possibly give you a better idea of how the structures looks like. That was the 3D view of the whole structures. So it's supporting by the bin and column. So the bin possibly is too big, but as a structural engineer, you need to decide which one is the right size. After you run the analysis, then you can run the design accordingly. So let's draw this one from this bin continuously. We still have this one from here to here, and then from here to here, to supporting the other part. So we need to have a bin supporting this one from here to here, and then another one from here to here. Okay, and then close up this one to here. So this is the structures, and the beam you put in along the staircase is not always necessary, but sometimes put in a bin there to make it easy for you to decide to hold the structure together easily, and then it's up to you, so as engineers, to decide whether you want or not. But if you don't put a bin here, so the slab has to be strong enough to withstand all the loading on top. So for a slab of 150 millimeters thick, and then possibly sometimes it's not that easy. So let's have a look at the overall structures. So this is the way these structures look like. So to enable us to do this one, what we should do is that we possibly to change the setup of the way the slab has been displayed. So maybe by tick this one to fill in the interior, by tick this one and apply, so make it easy to see where is the slab, where is the bin. So once you finish this one, actually basically what we need to do is that the loading we need to apply. So to do that one, as we mentioned before, we have that all the floor area subject to the dead load and live load. So we add the dead load first. So the dead load, we have the density of it is surface loading. It is 0.7. So that's in Z direction we put in here negative 0.7 kilometers, that kilonewton per meter. So in here, because it says the kPa, so the kPa means that it's Newton per meter square. So we are having the 0.7 kilonewton per meter. So here we should not put in the 0.7, we should put in 700 kPa instead. So once you finished, click on apply, and then you need to apply this one to all the loadings. So to do that one, the other easiest way to do is that you possibly want to change to select mode, and then select all the slab, because all the slab have this loading. And then when you click on this window again, it said it's applied to the flat number 1 to number 15. And then you click on apply, so all the loading has been applied to the structures. So once the dead load has been added, so we need to create the live load. So just click on live and then add to it. So once finished, then you need to decide the same again for the loading by click on the load definition and use the surface loading, and then choosing the surface loading UDL. In the live load we have 1.2, so that which means this is the 1200 kilonewton that per meter square, so that's equal to 1200 kPa. So once finished, click on add, and then again that's going to apply to the same amount, that floor slab you have in here. So just click on apply. So it's loading is on. So any loading we have, let me have a look. Yeah, that's what we have. So once we have the loading applied, actually you can run the analysis for MultiStorey already. So let's save this one as that in the let me choose where it is the videos and the MultiStorey building. Let's save this one as the first part, story 1. Story 1, and maybe put in some more step 1 to make sure that I can remember properly, and just save it. So once this is done, and you can run the analysis already. So let's click on the analysis, calculation. So that's done. So once this finished, you can have a look at the results. So for example, for the result diagram, and you can have a look at the deformation first, which is this one, and then you can apply, and then let's see the deformation of the whole slab. So, okay, and then that's the dead load, that's the live load. Okay, that's the live load. And so if you want to see the more details of these structures, then you can click on this one properly, that changes layout, and then also you can use animation to see. So say for example, you see how the structure is deformed. And so let's stop the animation, close this one, and make sure this one disabled, so we can back to the original view. And I think you can change the calculation mode to the original mode by clicking on this one, and that possibly give you a better view of the whole structures. So you can start again the animation. So let's see the animation of the deformation. Okay, stop this one again, and disable this one, apply, and to enable us to see the diagram for the bending moment, so you can click on this one. So the NY is a major bending moment we want to have a look, so you can see by click on the NY and apply in here. So that's given you the idea of what is the bending moment of the bin looks like. Okay, so with this loading on. And also what you can do is that you possibly want to see the reactions, and then you can feel free to do that reinforcement if you carry out the design. So for us, we're possibly interested in to see how is the stress contour distribute inside the slab. So what you can do is use the slab in here, and then you can choose the the membrane force inside this one, or you can find out the bending moment in the membrane, so along the x-axis and along the y-y direction by click on this one, and then click on the apply. So that's showing you the bending moments distribute inside in this area. So, and also you can quite easy to find out the tension stress along the x-axis and y-y by click on this one. So that gives you the results of different analysis, and so you can change to find out this one yourself. So let's come back to the one we have in here, and okay, once you've done the first story, you want to see how we can actually copy to the second story. That's maybe the easy things we can do in here. To do that, we need to switch back to the geometries in here. Then once you back to this layout, you see on the left hand side you have navigation panel, which allow you to switch between story to story. So on the story one, what you need to do is right click on this one, and then what you can do is that you can copy the story from one to another. Sometimes these filter structures has been ticked, and then so that's why you cannot copy story. So to enable you to do this one, you need to maybe untick this one, and then again and right click on this one and choose the copy story. And once you copy, that will give you a chance to define that the height and how many story you have, and then the location this one copy to, so it's selected in here. So once this one has been done, then you can click on OK, and then click on add to this one. So the structure has been copied. You can see the story is copied one to another. And after that, what you can do is you can have a look at the load. If you click on the load, and then all the loading, all the dimensions, all the size has been copied up to the next level as well. So excuse me. And then it's quite easy to produce. So once finished this one, you can actually start to run the analysis directly without any problem. And errors. Yes, that possibly the error. So the elements define a story different from the element. Yes, that's possibly the one you define the ground floor, move on to this one. So that's possibly the problem here. So that's what we can do. So we can just simply delete this one by highlight this one and delete this one. And then what we could do is that we can recreate this one and thickness correct, and then just choose this one here. Okay, so this next step is generate. Now this one is generate for the first floor. Then what we need to do is that we need to apply the loading to it properly. So what we can do is that let's leave it this one. You can do the loading yourself, and then maybe leave no loading in here. But you can do this one in your analysis quite easily. So let's just continue to run the analysis again. So this time should be everything fine. Then you can come back to the result mode and the diagram, and this time you can maybe see the deformation and try this one and that animation if you want. Okay, so let's stop this one. Let's stop this one. Close and disable this one. And also if you want to see the contours of the map, and then this time you can see the bend moment along the YY, then you can apply. So that's the contour you can see from the structural analysis. Okay, hopefully that's enough for you guys to carry on. So you can do the entire building if you want. Thank you so much. Bye for now.